Now, collisions, before we analyze collisions and classify collisions, we will try to consider now the line of impact. Based on that, we make classification later. First one is line of impact. When the collision is taking place between the bodies, what is the line of impact? Say for example, this line of impact depends on shape of the body. If your colliding bodies are spheres, let's assume that there is a sphere, another sphere, it is colliding. When there is a collision between the spheres, there is contact point here. This is the point of contact. At this may be moving and this may be at rest, or both may be moving in opposite directions, both may be moving in these directions. Various possibilities are there. In that, if this is interacting with that, if it is colliding with this or this is colliding with that, then there is going to be interaction force. That interaction force usually will be perpendicular to the surface of contact, that is normal to the surface of contact. This surface is the surface of contact, means along this surface this is a contact point. Contact point is lying on this surface and interaction force will act along this direction. This interaction force direction usually gives the line of impact. Now, in case that depends on nature of the bodies, shape of the bodies. Say for example, we have an inclined plane, wedge is there. A body is falling on it and colliding. Then in that case, the interaction was point of contact will be like this. Then normal reaction in this direction, the impulse force ball will experience and interaction force wedge will experience is this, that is perpendicular to this surface of contact. That is the surface of contact. When in the case of bodies are not moving, one of the bodies is at rest. Say for example, we have a sphere rest on the surface. If a stick, that is Q is hitting it in this direction, then the impulse direction or interaction force direction is this. Or if a body is, some sphere is like this, a plate is or bat is hitting it. When the bat is hitting it, this is the direction. When it was at rest, it starts moving in this direction. Therefore, generally when a body is at rest or bodies are at rest, when they start moving under the action of impulsive forces, then that direction usually considered as line of impact. Based on the line of impact, we have classification of collisions. Collisions classification. Broad classification is, one is head on, second one is oblique. Or head on collision also is called direct collision. Oblique collision is 2 or 3 dimensional oblique collision. Collision is head on or oblique. Based on this classification is based on line of impact. This classification. There is another classification of collisions based on energy. Based on the energy of the colliding bodies, based on the energy, we have collisions classification. One is elastic, inelastic, and in this case inelastic we have inelastic and plastic. Completely inelastic we have collisions. Like that we have classification. Head on and oblique, what is the basis? This classification is based on the line of impact. This classification of the collisions is based on energy consideration. So what is head on and oblique? In case if the bodies are, say for example, 2 spheres going along the direction, along a straight line on a horizontal path, if they are, this may be at rest, this may be moving, they are initially moving in the towards right. One, this is one sphere, this is another sphere, u2 velocity, u1 velocity, it is going masses are m1 and m2. Now, in this case, if u2 is less than u1, this sphere is going to hit it. During hitting, what will happen? This will exert force on this. The force it exerts on this, that is interaction force, acts along the line joining them. So, after collision, if the colliding bodies continue to move along the same line in which they were moving, that is line of motion of the colliding bodies continues to be same even after collision, which is equal to before collision. In that case, that collision we call it as head on. In this case, the interaction impact, line of impact is along the line of motion of the particles, that is before the collision, after collision, motion of the bodies coincides with the line of impact. If line of impact direction, motion of particles, motion velocity direction coincides, in that case that collision is called head on collision. In the case of oblique collision, a body, let us assume that there is a sphere at rest, this is at rest, another sphere is moving in this direction. When there is a touching, that is interaction is there, let us assume that the sphere is hitting this sphere in this way. When it is hitting it, moving in this direction, before collision, the first sphere is moving in this direction. Let us assume that this is at rest before collision. Now, during collision, what happens? The interaction force acts perpendicular to the line of surface of contact. Therefore, interaction force acts in this direction. That is called line of impact. Impact line is this, along which interaction forces act. But before collision, this body is moving in this direction. After collision, this may be moving in this direction, this may be moving, the first one may be moving in different directions. So, therefore, in this case, this collision we call it as oblique collision, because after collision, before collision, they are different from line of impact. So, therefore, when the line of impact coincides with the direction of motion of the bodies before collision, after collision, such collision we call it as head on collision. And oblique collision is the one where velocity, motion of the bodies before and after collision, there is different from line along which impact forces act. So, therefore, that is oblique collision. And the next one is classification of the collisions based on energy. What is that energy we use for classification? It is the kinetic energy of the colliding bodies. The kinetic energy of the colliding bodies before and after the collision is same, that is total kinetic energy before collision, kinetic energy of the bodies, colliding bodies, total kinetic energy before collision is equal to kinetic energy after collision. That is what we call it as conservation of kinetic energy. If the kinetic energy of the colliding bodies is conserved, in that case such collision we call it as elastic collision. If the kinetic energy is not conserved, in that collision it is inelastic or plastic or completely inelastic. In what way it is different from inelastic case and perfectly inelastic or plastic case? In the case of perfectly inelastic collision, the colliding bodies have common motion after that, that is they will have common velocity, maybe together they may be at rest or together they may be moving, but velocity is common among them. All the colliding bodies move with common velocity. In such cases, such collision we call it as the plastic collision. So, therefore, this is classification we have based on this. Next one is what else other we have to consider in the collisions. Collision as an interaction where external forces are going to have least influence on the colliding bodies during collision time. Otherwise, external forces may be acting, but during collision time we assume that large interaction force acts on them. When compared to those large interaction forces, gravitational force or such external forces are very negligible. That is, impulse the interaction forces produce is very large when compared to the impulses produced by external forces. Usually we ignore the effect of external forces during collision time. Since collision is an event interaction involving no external forces, the linear momentum of the system is to be conserved. Therefore, whenever we identify the event as collision, first thing we have to consider is the momentum conservation. Linear momentum of the colliding bodies must be conserved. That is, collision before, event before, means before the collision, total linear momentum of the colliding bodies must be equal to the total linear momentum of the system after collision, that is colliding bodies. So, therefore, first one for collisions, main thing, important thing you have to consider is conservation of linear momentum. Is a vector, linear momentum is a vector quantity, therefore, conservation of linear momentum is the point, that is momentum. Collision, whatever the event we call it as a collision, one is the conservation of linear momentum. Next one is, depending upon the nature of the collision, kinetic energy may be conserved, may not be conserved. If kinetic energy is also conserved, such collision we call it as elastic collision. And in the case of inelastic collision, conservation of linear momentum is there, but kinetic energy is not conserved. Even in the plastic collision, kinetic energy is not conserved. So, therefore, common thing for all type of collision is conservation of linear momentum.